New research has brought us closer than ever before to finding Planet 9, a hidden planet at the far edge of our solar system. It might also rewrite our whole understanding of the outer solar system and how it formed. Many scientists think Planet 9 is likely to be real because it would help explain bizarre patterns in the outer solar system. In the Kuiper Belt, a gigantic donut-shaped ring of icy debris in the outer solar system, objects move on weirdly long, stretched paths. Many of them also point in the same direction. This looks as if something is pulling on them. Besides, in 2016, scientists noticed that 6 icy objects in that region were moving in unusual ways. Their orbits seemed to cluster together, as if something was guiding them. The chance of this happening by random coincidence is about 1 in 500. One idea is that a large, unseen planet is using its gravity to push and pull these objects, shaping their orbits. Researchers used computer models to figure out what it could look like. The results suggest Planet 9 might be about 7.5 times heavier than Earth and could orbit extremely far away, around 600 times farther from the Sun than Earth. For comparison, Neptune, the farthest planet from the Sun, is only about 30 times farther. At such an enormous distance, the planet would be very hard to see, but its gravity could still affect distant objects. But that's not all. In 2025, researchers at Princeton suggested there could be another hidden planet, Planet Y. And it could explain an unusual tilt in the outer solar system. You see, normally, the solar system forms a flat disk around the Sun, where planets and icy objects move in the same plane. But far beyond Neptune, about 80 to 400 times farther than Earth is from the Sun, this flat shape starts to bend and shift. What could affect it? A small hidden planet, maybe as heavy as Mercury or Mars, orbiting far away on a tilted path. Its gravity could slowly pull on the outer solar system and change its shape over a long time. The thing is, if nothing was pulling on it, this tilt would slowly disappear over millions of years. But since it's still there, scientists think something may keep pushing and shaping it. Hopefully, the Vera C Rubin Observatory in Chile will give us the answers. This new observatory will scan huge parts of the sky using a very large 27.5-foot mirror and an extremely powerful 3,200 megapixel camera. This will allow it to detect super faint and distant objects. Its main goal is to map the solar system in detail, including regions far beyond Neptune where Planet 9 and Planet Y might exist, confirming or ruling out their existence.
Well, apparently Earth may not be the only place where you can have a glass of water. Scientists found one more world that looks very promising, because it might have liquid water on its surface. Even Mars can't compete with that. This planet is not too far from Earth and orbits a star called JG 887. Look, this is Earth and this is the Sun. Zooming out, see this speck of light? It's this star we're talking about. This star is 10.7 light-years away from ours. For comparison, Earth is way less than 1 light-year away from the Sun. And a spacecraft could get us to the Sun in a few years. But with our modern technologies, we would need over 270,000 years to get to that star system. And still, that's close, by space standards of course. Scientists call the planet a super-Earth because it's bigger than our planet, more than 6 times the mass of Earth. That's heavy enough to have strong gravity and a thick atmosphere. Another interesting thing is that, unlike many stars of its type, JG 887 doesn't flare up much. Big stellar flares can blast away a planet's atmosphere, The fewer flares there are, the better chance a planet has of holding on to air, water, and maybe even life. When astronomers talk about the habitable zone around a star, they mean a spot that is not too hot and not too cold, where water could exist on the surface. But water isn't just about temperature. You also need air. Without an atmosphere, any water would evaporate or boil away instantly. According to researchers, the star's planet, JG887d, might actually have an atmosphere, which makes it a true habitable zone planet. Now, scientists already found 2 other planets around the same star back in 2020. But both were too close to the star, way too hot for liquid water to survive on their surfaces. The research also hinted at a 3rd planet around this star. But at first, scientists weren't completely sure it was real. They thought the data could have been a fluke or weird blips in the measurements. But after 5 more years of watching the star, the planet was confirmed. It orbits its star every 51 days or so you'd celebrate your birthday once every 51 days there. It's even shorter than a year on Mercury, which means the planet is very close to its star. Then why doesn't it burn up and could even host life? The thing is, the star, GJ887, is smaller and dimmer than our Sun. That's why it doesn't blast this 3rd planet with heat. So even with a shorter orbit, the planet's temperatures should be only a little warmer than those on Earth. Now, the good news is that the conditions on this new super-Earth might actually allow water to pool somewhere instead of evaporating immediately. No wonder this discovery is a big deal. For one thing, we might finally find life beyond Earth. Because where there's liquid water, there's a good chance of life. Plus, if we ever had to leave Earth, GJ887d could be a strong contender for our new planet. Now, one big problem for planets around small stars is flares. Many red dwarfs blast their planets with intense bursts of radiation, stripping away any atmosphere. Without air, water can't stick around, and life doesn't have any chance to survive. That's probably why Proxima b, the nearest planet outside our solar system, likely has no atmosphere at all. But GJ887 is unusually calm. It doesn't flare like other small stars. Of course, this might just be temporary, or it could last for billions of years. Either way, it makes GJ887d more promising for holding on to air. The planet is also heavy, which means a lot of gravity. It would make launching rockets tricky, and it wouldn't be an easy feat to go for a walk there. But heavier gravity is also good for keeping a thick atmosphere. If it developed on the planet, it could protect the surface and trap just enough heat. Unlike some planets, our guy doesn't pass in front of its star from our point of view. That means we can't easily measure its atmosphere by seeing how the starlight filters through it. Instead, astronomers need to use the radial velocity method, which detects tiny wobbles in the star caused by the planet's gravity. We still have a lot to learn about this world that might turn into a top travel destination one day. Every year, astronomers discover new planets outside our solar system. So far, we've found over 6,000 exoplanets, planets orbiting stars other than the Sun. What interests us the most are planets that could host life, or at least have the right conditions for it. The big goal is finding stable liquid water on the surface, not frozen solid or boiling away into space. For water to stay liquid, a planet can't be too far from its star. Too far and all the water will freeze into ice. Too close and it will boil off like water on a stove. And since every star is different, each one has its own habitable zone depending on its size, temperature, and brightness. So far, telescopes around the world have found about 70 planets in a habitable zone. But only 30 of them are rocky, like Earth, where oceans might actually exist. The thing is, only rocky planets can have oceans because they have a solid surface where water can collect. Plus, such planets also have gravity, which helps keep water in liquid form. Without it, water would quickly evaporate into space or freeze solid. Now, having these conditions doesn't mean life is guaranteed. Venus and Mars are technically in the Sun's habitable zone, but Venus is a roasting oven and Mars is a frozen desert. Life there seems unlikely. Or take this planet, for example. This super-Earth is 20 light-years away. Astronomers spotted it in January 2025 using telescopes at ESO in Chile. At first it sounded very promising, but the planet's orbit is very stretched out like a long oval. That means it swings in and out of the habitable zone during its year. When it's far from its star, freezing winter lasts forever, not exactly life-friendly. But even a perfect orbit isn't always enough. In the Gliese 667c system, 22 light-years away, astronomers found 3 planets in the habitable zone. But one, its planet F, is tidally locked. One side always faces the star and is scorching hot. The other side is in permanent shadow, freezing cold. Life could only survive in a thin strip between the two regions, or if strong winds spread heat across the planet. A true habitable planet also needs protection from cosmic rays, like a magnetic field and a thick atmosphere. Otherwise, radiation from the star will fry any chance of life. Take the TRAPPIST-1 system, discovered in 2016. 3 planets orbit in the habitable zone, but TRAPPIST-1b is tidally locked, gets blasted by stellar radiation, and has no atmosphere at all. The other 2 planets might have atmospheres, but we don't know yet if they can block out harmful radiation. Red dwarf stars, small, cool, dim, and also the most common in our galaxy, make things trickier. Their habitable zones are close to the star, so any planets there get hit by strong solar flares. Our closest potential second home, Proxima Centauri b, faces this problem. Unfortunately, it doesn't transit or cross its star from Earth's point of view, so we really can't study its atmosphere or see if it can protect life. And even planets that tick all the boxes, the perfect orbit, habitable zone, atmosphere, can still be nightmarish, like Venus. A circular orbit, habitable zone, thick atmosphere, and yet it's basically an oven with crushing pressure inside. Even Earth itself isn't perfect for life everywhere. The North and South poles are freezing. The Atacama Desert is almost completely dry, so life struggles there too. That's why astronomers aren't stopping at planets in the habitable zone. They're now hunting for signs of life in the air. Certain gases can hint at life. CO2 and methane might come from biology, or they might not. Some gases, like dimethyl sulfide, are thought to come only from living things, but scientists aren't 100% sure. So, the tricky part is, how can we tell if a gas is made by life or by rocks and chemistry alone? Well, we've got new telescopes, like ESO's Extremely Large Telescope. They can give us much more detail. They could help us find more planets in the temperate zone and even reveal certain traits that would tell us if a planet is truly habitable.
Right now, 4 tiny, Earth-like planets are chilling around one of the closest star systems to us. We're talking second closest. These little rocky worlds are each about 20 to 30% the mass of Earth. So not quite Earth 2.0, but still pretty solid. Will one of them become our new home one day? Well, all of them are pretty close, so future humans might actually visit them someday. Not like next year or anything, but we could potentially send missions there. Don't expect any extraterrestrial neighbors, though. Those planets probably aren't home to life, or at least not anything we'd recognize. Let's take a look at them. The planets are called Bernard B, C, D, and E. How creative, huh? The innermost has a mass of 26% of Earth. The second one is a bit bigger, with a mass of 30% of Earth. The third one has 4% more mass than the previous. And the outermost is... no, it's not the biggest. Actually, it's just a baby, with a mass of 19% of Earth. All the planets are likely rocky, like the inner planets of our solar system. They orbit their star very closely. That's why they only need a few days, under a week, to make a full circle. Now, what about that star these little guys are circling? It's called Barnard's star. Astronomers have always had a hunch there might be at least one planet orbiting it. First off, this star is super close, in cosmic terms of course. Only the Alpha Centauri trio is closer to us. Barnard's star is just under 6 light-years away, which is basically next door. At the same time, it's not like our Sun. Barnard's star is a red dwarf, the most common kind of star out there. It's got only about 1/6 the mass of the Sun. But red dwarfs are a goldmine for learning about planets outside our solar system. And studying Barnard's star can help scientists figure out what planets around single stars, like our Sun or this red dwarf, are like. Or what kind of environments red dwarf planets might have. And most importantly, we might finally find the answer to this super important question. Could any of these places actually support life? For the longest time, scientists thought there might be a big Jupiter-like gas giant hanging out near Barnard's star. All because the star has a little wobble. It looks as if it shifts towards and away from Earth over time, so something might be tugging on it. Interestingly, it wasn't a giant planet doing the pulling. According to a study from March 2025, it's actually 4 smaller rocky planets, each about 4 times the mass of Mercury. One day, they ganged up and started tugging on the star together. These planets are incredibly close to their star, so close that they can whip around it in just a few days. Sadly, because of that, they might be way too hot for anything like life. Besides, since these 4 seem to explain all the star's movement, the researchers think there's probably nothing else orbiting the habitable zone. So, there's no Earth 2.0 orbiting around Barnard's star. Still, it's an awesome find, especially since this star is basically our cosmic neighbor. Plus, the system might not stay off limits forever. With nuclear fusion engines or light sails, futuristic propulsion systems that could make the trip way faster. We might probably go there one day. And then we'll finally figure out if these worlds are really lifeless and maybe even colonize them. Now, let's see how scientists found the star's hidden planets. Normally, astronomers spot exoplanets when they catch them crossing in front of their stars and blocking some light. But Barnard's star is tricky because, in our view, it's like we're looking from above the system, so its planets don't block the light in the usual way. That's why they call it the Great White Whale of planet hunting. To get around this, researchers used a super sensitive instrument called Maroon X attached to the Gemini North telescope on Hawaii's Mauna Kea volcano. Over 112 nights, spread out across 3 years, the telescope picked up tiny changes in the star's movement. These shifts let scientists figure out how many planets must be tugging on the star, as well as estimate their sizes. At first, they found 3 planets. But then they used another device, deliciously called Espresso, and located at the Very Large Telescope in Chile. And only after a shot of this espresso did they find a 4th planet. By combining the data from both instruments, they were able to more or less confidently say their findings were solid, not just random glitches in the data. Even though red dwarfs, like Barnard's star, are the most common type of star in the universe, most are way too far for us to see planets around them easily. These new findings suggest that small rocky planets could be pretty common around these stars, and that's huge for future discoveries. Now, finding new exoplanets is cool and all, but it might be even more exciting to dwell on their birth and evolution. And a recent study has made the sweetest discovery ever. Newly born exoplanets might actually look like Smarties, that popular British candy, rather than spheres. We've always kinda assumed that baby planets are born ball-shaped, but they might be oblate spheroids instead. A team of scientists from the University of Central Lancashire in England used computer simulations to build a model of the formation of planets in dense gas disks surrounding young stars. After that, they compared these models with actual observations and noticed that the young planets took pretty unusual shapes. The thing is that even though almost 6,000 exoplanets have been discovered so far, astronomers still don't have a clear understanding of the sequence of events marking their birth and early evolution. But this new research might finally shed light on this process. So, the astronomers examined the formation mechanisms of gas giant planets like Jupiter and came to the conclusion that planets built up from their centers. After that, the researchers focused on the initial shapes of such planets. They were also interested in how they could encourage the growth of these planetary seeds. How could they turn into such massive planets, some of them bigger than our solar system's largest giants? According to the standard theory of the formation of planets, such growth happens gradually and smoothly. First, dust particles start to stick together, turning into larger and larger objects. This process lasts for a very long time and is known as core accretion. It's the model of planet formation scientists favor. There's another theory, according to which planets' birth might happen over shorter periods of time. This data involves a protoplanetary disk, a disk of gas which makes up 99% of its mass, and dust, around 1%. This disk orbits a newly formed star, and hypothetically, planets might form from this cloud. Protoplanetary disks are likely to be common byproducts of star formation. They might range in mass from 0.001 to 0.3 solar masses. Inside such disks, matter slowly moves inward, and dust particles grow bigger, to the size of pebbles. At one point, after 2 to 3 million years, a giant rotating protoplanetary disk breaks into pieces, and that's how baby planets are born. This theory is known as the disk instability model. As for the model built by the team, it seems to support this second, less favored theory: rapid planet formation through disk instability. All because this theory explains how large planets can form relatively quickly at pretty large distances from their host stars. As for the weird flattened shape of these newly formed planets, it might be due to the material falling onto them. Most likely, it goes mainly to the poles of new planets. One of the main conclusions of the research is that the appearance of young exoplanets, as we see them from Earth, may vary depending on how they're angled. If Earth is directed face on to an exoplanet, it will seem that the latter has a traditional spherical shape. But if seen on edge, a baby exoplanet will look like a real smarty. The team is going to continue to investigate the formation of planets with the help of an improved computer model. They believe they can find out the role the environment around a young planet plays in affecting its shape and formation.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.